So here is the question that I ended the previous part of this lecture with. And all you needed to use was this idea of energy as the capacity to cause change. If you take that relaxed spring and just release it or leave it, it's just going to sit there doing nothing. That compressed spring is presumably being held compressed, and if you release it, it's immediately going to start oscillating, right? It is going to change. And if it is pushing up against anything, it's going to tend to launch that thing. And so the answer here is B. The spring, a compressed spring, has more energy than a relaxed spring. Similarly, a stretched spring has more energy than a relaxed spring. We'll see spring energy again later, but what we've already seen is that a spring has its minimum energy when it's relaxed. The hammer and nail example lets me do one more thing, and it's to identify that we've just seen two different types of energy. And for now, those are the ones we'll work with. We'll find other types of energy as we go along. Because we found two ways to give the hammer energy. We could make it move. And so this is an energy of motion, and we'll call this kinetic energy. We've encountered this word kinetic many times. It simply means to do with motion. So this is energy that things have because they are moving. But the other way we could give the hammer energy, give it the capacity to do work on the nail, was to lift it up higher than the nail. And so this is an energy of height. And we'll call this gravitational potential energy. Now, a lot of you who've encountered this already in other courses will want to just call it potential energy and leave it at that. But as we'll see, there are other kinds of potential energy, and so I'm going to insist that you be more specific. This is gravitational potential energy. So a perfectly good alternate name for this course would be, how many ways can we describe a ball being thrown up into the air? So, well, let's do it again, but this time we'll use energy. So you throw a ball straight up, and on the way up, it starts off just as it leaves your hand, and it's going fast. And so it has a lot of kinetic energy, but it's low down, so it has not much gravitational potential energy. But now, a little later, it's at its maximum height, and so it's momentarily at rest. So at that instant, it has no kinetic energy, but it has gone higher, and so it has more gravitational potential energy. And so what we can say is that on the way up, its kinetic energy was transformed into gravitational potential energy, and we'll write it this way. Now on the way down, that process reverses. Here we are at maximum height again, and so still kinetic energy is 0, and it's got lots of gravitational potential energy. And as it falls downward, it speeds up, so eventually it has lots of kinetic energy, but it's now lower down and it has not much gravitational potential energy. And so on the way down, its gravitational potential energy got transformed into kinetic energy. Let's check your understanding. So consider an air puck, and it's on the end of a spring, and everything is horizontal. The air puck is starting stationary with the spring compressed, and it's then released. So the puck is going to be pushed by the spring, and a little while later it will be moving, and the spring will momentarily be at its equilibrium length. So in this process, did the system's kinetic energy increase or decrease, and did its gravitational potential energy increase or decrease?